This is a video on how to solve trusses. So one of the first things you need to know about trusses is that there are supports that determine the amount of forces on the truss. Now these supports help you figure out whether or not it's statically determinate. And there are two main types of supports. Point supports, which provide both an X force and a Y force, and roller supports, which either provide an X or a Y support. In this case, to make it statically determinate, we need to use both a point and a roller to equal 3 support forces.
First thing before we even attempt to solve for the truss, we need to check if the truss is statically determinate. And if it's not, we can't solve it at all. Now, the formula for static determination is 2j equals m plus s, where j is the number of joints, m is the number of members, and s is the number of support forces. Now, as you can see, we've already solved this for our truss. Now, for where it is 2 times the 5 joints equals the 7 members plus the 3 support forces. Now, since both sides equal 10, the truss is statically determined. Now the next thing we're going over is the forces on the truss. Now, the forces determine what the support forces are and how that force is applied to each member of the truss. Now, we're gonna show you how to solve for the support forces, but because of one simple rule, all forces equal 0, and so all we need to do to find one we do not know is add the other ones together, and as we did up here. See, since it equals 0, negative 12 times 12 minus 9.7 plus 24 times REY. Now we're going to solve for REY on this one. Now, now if we multiply those together, we get 0 equals negative 144 minus 63 plus 24 REY. So now if we add those together, we get negative 81. And when we bring it to the other side, it becomes 81 equals 24 REY. And now we divide that, 24 on both sides, and we get REY equals 7.5.
After finding one of our support values using the moment, we still have 2 unknown support values. To do this, we add up all the forces in the y direction and set those equal to 0, and then solve for the missing support force, and we add up all the x forces equal to 0, and we solve for the support force, which is currently unknown. It is important to trust to be able to calculate the force on certain units. To do this, use simple trigonometry using the height and length to calculate these angles. When you solve for the forces on a truss, you want to solve it joint by joint and keep it organized. You want to start with the joint and solve for everything you can at that joint, and then move on to the next joint. We're going to start at point A. So first you want to draw the free body diagram of point A. Arrows pointing to the right or up means that you would add those values, and arrows pointing down or to the left means you subtract those values. This is important when you calculate the sum of all forces in a direction. So first, you want to calculate the sum of all forces on X at point A. And so when you write all of these out, you see there's 2 missing variables. So we leave the sum of forces of X at point A for now, and we go on to sum of forces of Y at point A. Now, there's only 2 variables, there's only 2 inputs, and we know one of them. So we can solve for force on ABY, which ends up being negative 4.5. We can then use trigonometry to solve for both the force on AB, X, and the force on AB. Once we solve for both of those, we can plug in the value of force on ABX into the sum of forces on X on A to solve for FAC, solving everything on that point. This gives us 2 values and 2 variables that we can use later in solving. You then repeat that process for each point, setting up the y and x equations for each of the points and finding the missing variables. You might have to pause the video to be able to see each point. Here's point B. Here's point D. And sometimes you can't solve for all of a point. So if you can't, just move on to the next point. Then go back over to the point you couldn't complete, input the variables in, and solve them. And here's point E.